Hey, Miss Marion here. So we're doing Unit 1, Lesson 2. Make sure you have your workbook with you because we're going to be doing a lot of stuff in here. So get out your workbook and then come and follow along with me. All right, so just for kicks and giggles, so which one doesn't belong? So just kind of think about it, answer it in your head, come back to me. All right, I think the spotted one doesn't belong because it's spotted. Some people might think this one doesn't belong because it's a smaller one. Anyway, it was just something fun to go ahead and do, is get our brains going. All right, today our learning targets and what we're kind of covering is how does patterns change from one figure to the next. So yesterday we're working with patterns, today we're working with patterns again. And then how can I use a mathematical representation to show how I see a pattern? So by the end of today, we're going to be able to go ahead and understand a pattern and be able to show mathematically what that pattern actually is. So those are our I can statements and our success criteria for today. So this is what we're covering. All right, turn to page 13. On page 13, we have this picture, right? And it says, mark the way you see the pattern growing in the sequence of figures given. Describe in words the pattern you see. So I want to kind of see what's going on, but then also let's kind of put it in words what's going on. So go ahead and pause this, write down what you like, what's going on, and then come back to me. All right, so what's going on? Notice how we are adding 4 more to each of them. So we are adding, or there was added, it was added. Let's do that. So it was added 4 more dots at each minute. Okay, so I know that in the workbook it doesn't say to go ahead and write in words, but we're just going to write it in words. Sometimes it's a little bit easier to understand and know what's going on. So yeah, let's put that on there. And then notice how we also kind of circled what was going on. If you have colored pencils, it might be a little bit easier to do it that way, but that is up to you. And so let's go, but yeah, so this is kind of what we are looking at. So down on the bottom of page 13, I kind of added in extra step to kind of have us understand some different things. So question number 2 does assume the pattern continues the same way, and then we want to see what happens after 3 minutes. I'm adding also 4 minutes and 5 minutes just to kind of see what the pattern is. Sometimes we need to extend those out a little bit further to know what's going on. So go ahead and show me what the pattern is after 3 minutes, 4 minutes, and then also 5 minutes. So pause and then come back to me. All right, so at 2 minutes, here we'll put these ones in dark. So 2 minutes had 2, 2, 2, and 2. But then after 3 minutes, notice how we added 1 extra one. So each little wing has 3 in them. So with 4 minutes, they started with the 3. And again, we added 4 more dots to this picture, but they're at the end. And then what happens with 5, I'm gonna have to make this smaller. So middle, and again, we add 4 more dots to all of them together. All right, so this actually is helping with our pattern to kind of understand what's going on. Again, I mean, we can count how many are in there and figure out how many total, and eventually we're going to actually go ahead and do that. But again, make sure you understand this pattern because I'm going to ask you to do something else in a second. All right, so down on page 13, it says, how many dots are there at 100 minutes? So if you wanted to, you could expand it out. I don't suggest that because it will take for a long time to figure out this pattern or figure out how many dots there are. But kind of think about what we were doing before, right? And think about what that actually means, and then figure out what our picture will actually look at. So go ahead and pause and then come back to me. All right, so I noticed with the pattern is that we started with a dot in the middle, and then it would go all the way out, and it would have 100. Well, if we were doing 3, then it had 3 at the end. If we did 4, it was 4 at the end. When we did 5, it was 5 at the end. So if we're doing 100, then it would have 100 all the way at the end. So this is kind of our pattern. This is what it looks like. And so some of you might have said, oh, well, there's 400 dots. Because you're like, oh, each side has 100. So we have 4 sides and they're at 100, which makes the 400. But the problem is we need to remember that there's actually a dot in the middle. So I need to take my 400 and I need to add 1 dot to it. So then it's 401 dots that would be in this pattern. As far as how many dots are there at 100 minutes, it will be 401 because we still have that first one that's there. All right, so turn your page. We're going to look at page 14. And if you look at it, it says, how many dots are that at 10 minutes, or sorry, T minutes? Model the pattern using a table, graph, and an equation. Your model should indicate how many dots will be in the pattern at 3 minutes, 100 minutes, and 10 minutes, or sorry, T minutes. Be sure to show your solution related to the picture and how you arrived at your solution. All right, so let's kind of just backtrack just for a second. So we need to figure out how many. So it's kind of like yesterday we put the number n as the number of sides, right? We were talking about the pattern of the colored tiles and then the white tiles. So instead of putting n in, we're going to put in t. Because we're talking about minutes, they're just going to go ahead and put in the letter t. Could you use any variable you wanted? Absolutely. But we're going to go ahead and just put in t that's in there. So we want to figure out how many dots are at t minutes. So if we think about it, before we actually had it where we had it, so we had at like 0 minutes, we just had that 1 dot. And then at 2 minutes, we had it, or well, at 1 minute, we add 1 dot all the way around. At 2 minutes, we added the 2 dots. So kind of think about those patterns as far as what we had. And then we also talked about 100 minutes, where we had it where here, and it came out to 100, right? And this is where it was at 100 minutes, right? So at 0 minutes, we had this one. At 1 minute, we had the 1, right? And then at 2 minutes, and then we also did the same pattern with 3, and then 4, and then also 5. So let's kind of think about what's going on here. So we have that one variable that we started with, right? And then pretty much going from 0 minutes to 1, 1 to 2, and then 2 to 3. Remember where we wrote down what we were doing before on number 1? We were adding an extra, or we're adding 4 dots every minute kind of thing. So let's kind of think about it. If I put it into what we did last year as far as 8th grade, we would have it where like y equals mx plus b, right? Where b was the y-intercept, m was the slope. Or b is where we started. So where do we start, right? We started with that 1 dot. And then how does it change? Notice how we're adding we're adding 4 dots every single time. And we kind of talked about that. And it depends on what the time frame was. So how does it change? It changes by 4. And it depends on how many minutes we have. And we're going to put in t into that variable. And we're adding those together to be able to find out how many dots there are per whatever minute that we're actually looking at, right? So now it's, okay, so this is kind of an equation, right? And we have this equation. We want to figure out what that equation is. And so we kind of go ahead and look at it. So way back when, we were talking about what is called function notation. And function notation is the fancy way, let's rewrite our equation down here. Function notation is the fancy way of kind of saying things. So my equation is 4t plus 1. Instead of having, so we have y equals 4t plus 1. Instead of having the y, I'm going to have the fancy way. So this is function notation. So f of t equals 4t plus 1. So what it's saying is, here's an equation. My variable is t. So we've been kind of working with this a little bit, but now we're really kind of introducing this where it's a function of t. Here is an equation of t. And these were what are called functions. Well, last year in 8th grade, we talked about functions. Functions are the same as equations. And we can kind of look at it and see what happens on those different ways, right? And then if I say, okay, let's figure out at f of 2, right? So kind of like t equals 2. So at 2 minutes, if I put 2 into this equation, it will tell me how many dots I have at 2 minutes. So we kind of did that before. 4 times 2 plus 1. So I have 8 plus 1, which is 9. And if I go back to this picture here, this was the 2 minutes. Notice I have 1, 2, 3, 4, 5, 6, 7. Okay, so let's try it one more time. So we have 1 in the middle, 2, 3, 4, 5, 6, 7, 8, 9. So if I have, notice at 2 minutes, I had that 9 number for, okay, what is happening at 9 minutes. So this is what is the equation. So you probably want to write this somewhere, but this is our equation, and it's a function, right? A function of t, and this is our equation. And we can actually put whatever time frame that we have into this equation and know how many we're going to go ahead and have. So let's try this with the 100, because we kind of talked about the 100, how many we would have if I did f of 100 minutes, right? So at 100 minutes, okay, we can put it in there. So we're going to say 4 times 100 plus 1. Put it in calculator, press enter. We have 401. So we can say there will be 401 dots. Okay, so this is our equation. So if we go back to the questions that were asked before, it says we need to figure out an equation. We've figured out our equation. And then now we need to figure out a table and a graph. So the table is actually a little bit easier to go ahead and do first. So let's put a table together. So we're going to have our time, and it's in minutes. I didn't make enough room. So we have our time in minutes. And then we have our number of dots. So we start at 0 minutes. That's kind of our beginning part. And how many dots do we have at 0 minutes? We have 1. And then we have, after 1 minute, how many dots do you have? You can go ahead and count those, or you can use the equation. But if you look at it, we have 1, 2, 3, 4, we have 5. We talked about 2. At 2 minutes, there is 9. Think about 3 minutes. When you have that picture, you can go back and count those dots for the picture. So we can always use our equation. So we have 4 times 3, which is 12. Add 1, that is 13. And then if we think about like 4 at 4 minutes, so 4 times 4 is 16. Add 1, that is 17. Okay, so we can kind of see that pattern. And we've been working with tables, figuring different patterns and how they actually work. And notice how for every minute that we're going up, right? How are our dots changing? That's changing by that 4. That's why our slope that we made our y equals mx plus b, this is our change. This is how it changes, right? So if I was putting in just a time, so I'm going to put in a time, that is t. How would we figure it out? Well, it's going to be 4t, right? 4 times t plus 1. So this is how the table and that function or that equation come together. This is how we're figuring out these numbers. So now what I want you to do is I want you to go ahead and take this information. We have a table, and notice how on that page, on page 14, we have that graph. I went ahead and started labeling my graph with the numbers that I'm going to go ahead and put in there. Will you go ahead and plot these points on that graph, and let's figure out what's going on with that graph as far as the information that we've done with the table. All right, so I'm going to go ahead and plot these. So at time 0, I have 1. At time 2, I have 9. Right? And then I can keep on going on with that. So, at time 1, I have 5. Let's put that on there. And then at 2, I have 9. And then if I extended out this graph even further, which some of you might have done that, we can actually show the whole table on there and kind of keep on going forever, right? So this is actually showing what's going on as far as this pattern. So today we're trying to figure out patterns and actually how to show it and explain it as far as the different patterns, as far as these dots and how they're going. So one of the things we need to understand is how is the table or the graph changing? So notice how we had the +4 kind of thing. And this is what is considered the common. Here, I'm going to move this over just a little bit. So this is what is considered the common. That really doesn't look good. Let's try it one more time. Difference. Okay. Difference is kind of like how does it change? Okay, we're looking for this, and it's pretty much the pattern of the difference. And then we are actually going to label this as D. So D is kind of like, how does it change kind of information along with this. So with the D, so when we're dealing with patterns, the D is considered the thing that is being added. And it's always being added. So how do we do a subtraction? Remember, we can always add a negative. Okay, so D is considered the common difference, and it's through addition. So how is it being added? For this one, we're adding, or we're having that difference of 4. And we figured out through our table, kind of like what we've been doing in 8th grade last year. All right, so let's go ahead and let's kind of put everything together, and we're going to put some words, math vocabulary words that go along with it. So something we may think of a pattern as related to previous outcome. This is called what is called recursive thinking. This is what we were actually doing. So we started with our previous, and then we're doing something to it. So we're adding 4, and then we're taking that to previous, and we're adding 4 to get our end. This is what is called recursive thinking. And because it's kind of going over and over again, and it works with the previous. So just like with our table at time 1, we only had 1. We're adding 4. We're adding 4. And then we're also adding 4. So we can use a common recursive equation for this situation. It's the next equals the previous plus 4. And so, again, this is what is considered recursive thinking. And then explicit thinking relates to an input putting with an output. It allows us to jump to the 100 minutes. We were thinking about that. How did that 100 minutes without having to show what happened at 99 minutes. So recursive is what happens before. Explicit is just like, oh, we can go directly to that amount. So the equation that we had was y equals 4t plus 1 is an explicit equation. We can write the same equation using function notation as f of t equals 4t plus 1. The output is read as f of t. We've been kind of talking about that. And then t is the input. So we have the input, so we know the input is our x, output is our y, and then we're also doing the output as f of t. So we can put in a number, we can get in and something back. And then we did that in the units before. So when we graph the dot pattern on a coordinate plane, we can see that the slope of the dots is 4. This shows us that we add 4 dots for every minute. And that's what we did in our table. And that's how we also got our graph. A pattern or sequence of numbers with a common difference between the outputs is called an arithmetic sequence. Again, this is called an arithmetic sequence. This is what our unit is. We're going to be talking about sequences. And this is arithmetic sequence, is when we are adding information. If you want to go ahead and put this on page 15, arithmetic sequence is a pattern or sequence of numbers with a common difference between the output with them. So this is considered arithmetic sequence. The recursive equation is also on page 15. And then remember, if we need to go back to it, we can have the explicit thinking. So all of this is on page 15. This is kind of our takeaways as far as we're introducing sequences and what kind of sequences are we working with. So on page 14, our table, so representations of an arithmetic sequence. Our table shows common difference between terms of adding 4. Our graph, the line had, so on our graph, that line had a slope triangle of 4 or 4 over 1. The explicit equation is f of t equals 4t plus 1. And then the recursive equation is the previous plus 4. I would actually write all of this down on page 14. This is our takeaways. This is what we went over for today, is be able to, 1, understand that pattern, and also 2, show mathematically what's going on with that pattern. That's where the explicit equation came from. That's where the recursive equation came from, and then also that table and the graph that we were working with. All right, so let's kind of remind ourselves how to kind of go ahead and figure out. This is actually on page 17. So identify the pattern in the table and fill in the missing values. This is, again, these are things that we are looking at. Oops, sorry, it's on page 16. And then again, we're just looking at the patterns. So notice how our terms are going up by 1. Right? And then how did we go from 28 to 37? So how would it go ahead and figure that out? Okay, let's do 37 minus 28. So we're adding 9. Let's try that with the next one. Let's do 46 minus 37. Ooh, we're adding 9. So then 46 plus 9, 55. add 9, 64, add 9, 73. All right, so again, we're looking at patterns. Let's look at number 2. Again, we're pretty much adding 1 on the top. So pretty much we're trying to find actually the slope of this pattern, or of this table. So how do we go from 28 to 64? Okay, that's going down. All right, so number 2 is actually a little bit different. If I did 128 minus 64, I subtract off 64. But then going from, if I do 64 minus 64, it's 0. So there is actually a different pattern that's going along here. And so, I'm going to do 128 divided by 64. That's 2. So divide 2. So if I do 128 divide 2, 64. 64 divide 2. 32. Haha, the pattern is divided by 2. So let's take 32 divided by 2. 16. 16 divided by 2 is 8. 8 divided by 2 is 4. So last year we only did add and subtract. This year we're going to do add, subtract, multiply, or divide as our patterns. So sometimes we need to kind of stop and go, okay, what are we actually looking at? And then we can actually go figure out the rest. All right, here's another retrieval question. It says use the given equation to find the y values needed to complete each coordinate pair. So remember, with the coordinate pair, we have x comma y, x comma y, x comma y. So this is kind of the reason why we did our starter that we have. So for the first one, we're going to put 2 in for x. So we're going to say -4 times 2 plus 9. Grab your calculator, -4 times 2 plus 9. Oh, that's 1. Okay. Now let's go ahead and let's do our next one. So we're going to say -4 times -3 plus 9. So that's 12 plus 9. 21. And then we're going to say -4 times 0 plus 9. Well, that's 0 plus 9, so it's 9. So we're going to be using all this kind of stuff to go ahead and understand our practice problems. But again, this is kind of why we did our starter this morning. All right, so you are doing your check your understanding. Make sure you get into Canvas and do those assignments. And I will see you later. Have a good day. Thanks. Bye.